The absolute value graph has vertex 2, 1 and forms a V.
Welcome to Function Marsh. If you look closely at the bark on the shoreline, you will see our guiding map, F-IF.7b. Here, mathematical equations act as the actual waterways that guide how animals move through the environment. Watch how this heron wades through the water. She is not wandering randomly. She strictly follows a V-shaped path dictated by a mathematical rule.
Graph A of x equals the absolute value of the quantity x minus 2, then plus 1. Start with y equals the absolute value of x. Replacing x by x minus 2 shifts the graph right 2, and adding 1 shifts it up 1. The vertex is 2, 1. The graph is a V shape that extends in both directions. The vertex is a turning point, not a starting position. Equivalently, a of x equals 3 minus x when x is less than 2, and x minus 1 when x is at least 2.
Let's follow the heron to a different stream. Notice how her path abruptly hits a physical wall of thick reeds. Some mathematical paths have hard starting boundaries where backward travel is impossible. This stream charts a square root rule. Y equals the square root of x plus 1. The core constraint of a square root is that you can only evaluate it if the expression inside evaluates to 0 or a positive number. We find exactly where this physical boundary lies.
For the square root, x begins at -1.
By taking the expression inside the root, x plus 1, and setting it to be greater than or equal to 0. Subtracting 1 from both sides, we find our limit. The input value, x, must be greater than or equal to -1.
For f of x equals the square root of the quantity x plus 1, require x plus 1 to be non-negative, so x is at least -1. The endpoint is -1, 0, and the curve continues to the right.
Now it is your turn to test the water. Pause the video and determine if the specific coordinate point, 8, 2, lies on the next path mapped by a cube root function. This coordinate plane maps a smooth, curved path dictated by the new equation, y equals the cube root of x. To evaluate if our point is valid, we take the x input of 8. The output will be the number that when cubed equals 8. 2 times 2 times 2 is 8, so the cube root of 8 is exactly 2. Since the math evaluates perfectly, the point 8, 2 definitely exists on the path. You verify exact locations in the environment purely by evaluating the equation's rule.
Now add the missing piecewise and step cases. For p of x, graph x plus 2 when x is less than 0, with an open circle at 0, 2. Graph 1 minus x when x is at least 0, with a closed circle at 0, 1. For s of x, graph 0 on closed 0, 1 open, 1 on closed 1, 2 open, and 2 on closed 2, 3 open. Every step is closed left and open right. Because 2 cubed is 8, 8, 2 lies on the cube root graph.